Hi, my name is Cihan Asci, and I am a third-year PhD student in the Department of Electrical and Computer Engineering at Tufts University. My research mainly focuses on designing analog and RF circuits and sensors. Here at Tufts, I am working in Dr. Sonkusale's research group, Nanoscale Integrated Sensors and Circuits Laboratory. Before we move along, I would like to take some time to thank IEEE for organizing IEEE Sensors 2020 conference and giving us the opportunity to present our research. Also, I would like to thank everyone who has taken the time to watch our presentation. Thank you. Our presentation topic is Security Monitoring System using Magnetically Activated RFID tags. We will talk about a demonstration of a simple security monitoring sensor that benefits from an RFID technology and magnetic activation using reed switches. As we know, radio frequency identification or RFID technology uses electromagnetic fields to identify and track targets and tags attached to different kinds of objects. The basic RFID system comprises of a RFID tag or transponder, an antenna, and an RFID reader. The antenna from the sensor can receive signals from the nearby reader and then respond by sending the corresponding tag ID information back to the reader. In that sense, RFID technology enables unique identification and tracking of assets and inventory. Another important feature is there is no need for line of sight communication. So a few RFID applications are access control, retail, sensing, product and inventory tracking, identification, and monitoring the state of goods, for example, perishable goods. So the RFID technology uses three different frequency bands. They are LF, HF, and UHF, which are low frequency, high frequency, and ultra high frequency. So there are differences between these frequency bands, and the application is the decisive factor of which frequency band is going to be used. So we implemented our sensor in a North America UHF band that is 902 megahertz and 920 megahertz with a mid frequency of 915 megahertz. So a few reasons that I can say: it provides a high read range. It's the fastest growing segment of the RFID technology. Fabrication of UHF tags are it's very cheap. General applications span many markets, from retail, healthcare, pharmaceutical, life sciences, and transportation. Also, the data transfer rates can be 20 times faster than our HF versions. So the goal of our project is to implement an easy detection sensor system. So the primary objectives can be that we need a low cost and battery-free solution that also can be easily installed. As you can see from the figure, the entry detection sensing system, that such a sensor can be applied to detect, for example, an entrance to a room or illegal opening of a safe. So in that sense, we also strive for a different sensing mechanism, which in this case, it's based on magnetic actuation. So also it should be a small and compact sensor solution that comprises of a printed antenna because they are very cheap to fabricate. So let's talk about the working principle of the sensor. We connected a reed switch in parallel with the antenna and RFID chip. Hence, the sensor consists of magnetically controlled passive reed switch, a printed antenna, and a passive RFID tag. We print the antenna on a paper substrate. These components make this sensor very low cost, especially the reed switch. That is a circuit component, and it's controlled by magnetic field. The reed switch is of SPST normally open configuration, and it consists of 2 metal reeds and a plastic package outside. There are other reed switch types such as SPST, like normally closed version, but we utilize normally open reed switch. If we apply sufficient magnetic field nearby the reed switch, then the contacts close and therefore the electrical connection has been made. As you can see on the left, there are a few ways to connect switches to the antenna. The one at the top has 2 switches and the one in the middle has 1 switch. This connection is considered to be in series, but the optimal connection is connecting the reed switch in parallel as shown in the bottom, because it provides better impedance matching. Here, our basic goal is to gain ability to turn on or off the reed switch such that we have a control mechanism in the presence of a magnetic field. So the idea is acquiring the ability to switch the antenna based off the existence or non-existence of a magnetic field near the sensor. Here, as you can see on the bottom right figure, we fabricated a magnetic RFID sensor or Mag-RFID sensor on a paper substrate. And for the sensor fabrication, there are a few steps in the fabrication of the Mag-RFID sensor. First, we design our antenna in a CAD software. In this case, it's ANSYS HFSS. We take the output file, it's the DXF file. We use the laser cutter to generate masks. So masks can be peeled off one side, and we can stitch the mask to a paper substrate. Then we apply silver ink on the paper substrate on the surface. So we let the silver ink dry for a few minutes, and then once we peel off the mask, the antenna is then ready for use. So this is just basic screen printing technique to fabricate printed stuff. So we have designed an inductively coupled compact antenna that has a resonance frequency of 915 MHz. The antenna is designed in ANSYS HFSS by using the optimization tool. The formula here is the reflection coefficient for a one-port network, where the load impedance is 50 ohms and the source impedance is the RFID chip impedance. So our chip has an impedance of 18 minus j times 180. So placing these numbers into the equation and placing this equation in the optimizer tool, we had a reflection coefficient gamma. We set the optimization goal to be less than minus 20 dB, and the optimization variables are the length values as shown in the figure, the blue one. So the red curve in the return loss figure, it shows the return loss of RFID tag antenna. As you can see at the 950 MHz, it's better than minus 20 dB. Here are the figures for the antenna model with exact dimensions. It's on the top. And at the bottom, it's the fabricated sensor or paper substrate. As you can see, the dimensions of the overall sensor are 12 centimeter by 5 centimeter. It is very compact antenna. Since we are using a UHF tag, a reed switch, and as paper as a substrate, the overall sensor is extremely low cost. For the sensor measurement, we have a demonstration of the measurement setup that includes Mag-RFID sensor, Magnetically-RFID sensor, and the reader module. we affixed an external magnet next to the door, next to our RFID sensor. We used a reader module of AS3992DK micro RFID reader from AMS. And for the measurement, the initial distance between the magnet and the sensor is kept to be 6 centimeters at the beginning. So this renders the RFID antenna and tag to be unresponsive due to short circuiting. As a distance reaches around 11 centimeters, the magnitude of the magnetic field nearby the reed switch is not sufficient to turn it on. So the antenna starts radiating signals. So we take RSSI measurement as a signal quality measurement. It's the received signal intensity. So after 11 centimeters, the RSSI value jumps to 82%. This is how we detect if there is any opening or entry event. For the conclusion, we have presented a simple sensor platform that can be used security monitoring, and it's controlled magnetically. Important features of the sensor, we can say that there is no need for battery, which is a big plus. And it is cheap and it is easy to fabricate. It is compact and low profile. It is lightweight. Multiple sensors can be detected by a single RFID reader because each RFID tag has its own unique ID. So for the future, we plan to investigate this sensor further so that we can integrate this sensor platform with the IoT cloud for data logging. Of course, due to cost effectiveness, this overall sensor system can be also used for large scale security monitoring. Thank you so much for listening, and we will see you soon in Q&A session. Have a nice day. Thank you.